In this tutorial, you'll learn how to describe characteristics of functions. Here's a graph of a function with many different characteristics. As you can see from the vocabulary, we have sections that are both decreasing and increasing. We have sections that are perfectly straight and linear, sections that are curved or nonlinear, and we have sections that are horizontal or constant. You'll notice in the middle here, I have two dotted vertical lines. Those represent a specific section of the graph. And when we talk about a specific section of the graph, that's known as an interval. So a section is the same as an interval. So if I say to you in this red sentence here, the interval between x is 2 and x is 3, which is this area here, in between, is increasing, that means it's moving upwards, and nonlinear, which means it's curved. So let's look at that section between x is 2 and x is 3. In this interval, you'll notice that the graph is increasing from left to right, and it is curved, which makes it nonlinear. Let's take a look at another interval. This time, let's look at the interval from -2 to 0. I know those are the numbers because I see them written along the number line. So the interval between x is -2 and x is 0, which is starting from here and moving to there, if you look at the actual graph, it is going downhill, which means it's decreasing, and it is perfectly straight, which means it's linear. What you're going to practice today is determining the characteristic that you see or naming the interval of something that I describe. These are the words I want you to use today if you're describing the characteristic of an interval. You can choose between either increasing or decreasing, but you can't pick both. You are either one or the other. You can choose between linear and nonlinear. You are either one or the other. This is the other characteristic that you might talk about. Constant is when you neither increase or decrease, and you're staying the same. And the word interval is when you talk about a specific section of the graph. When you are discussing an interval, you must be very specific about the starting left-hand point and the ending right-hand point. And we use those as x values. Let's take a look at another graph. When you are naming your sections or your intervals, you can use different symbols. You can use English words or you can use math inequalities. So let's take a look at this green highlighted section here on the left. If you wanted to describe to me this interval of where the green section starts and finishes, then you might use one of these two symbols. You might say from x is equal to -3 to x is equal to -1, or you might say this inequality here. -3 is less than or equal to x, which is less than or equal to 1. Sometimes you might even say when x is between -3 and -1. So those are the different ways you can describe the actual interval. But in addition, you can actually describe the shape of the graph. So one thing you need to describe to me today is what section to look at. And then the second thing is how does it appear in that section. All right, let's see if you can write down an interval that is actually decreasing. When you write down your answer for your interval, you can use this format, or you could even use the inequality format. If you're on a Zoom call with me, then that's going to be difficult for your keyboard. But it is a possibility if you're using paper and pencil. All right, were you able to name an interval that was decreasing? There are two possible choices. This area is decreasing, and so is this area. This one is not decreasing, it's constant. So the two areas highlighted in red are from -1 to +1, and the other area here, which I'll highlight in blue, is from 3 to 5. You could also say it in English. Between x is equal to -1 and +1, or x is equal to 3 and 5. How about this one? Can you name an interval that's nonlinear? Use correct interval notation. All right, you have two choices. You have this area that starts and ends, what I highlighted in blue, or you have this area which starts and ends, where I highlighted in red. So the area in blue is between -7 and -3, and if you answered the area in red, you would have said between 3 and 5. All right. How about an area that is increasing and linear? Write down that interval now. All right, you ready to check your answer? Now you have to be both moving in an upward direction and perfectly straight. So this area is upward, but it's not linear. This area is upward, and it is linear. So we're going to note its starting point, which is -3, and its ending point, which is -1. That area is both increasing and linear. That is the only answer for this question. Another type of graph you might be shown is one that's written in context. That means there's a story behind what you're looking at, like this one here. A bicycle club is riding. They ride for a certain amount of hours, 1, 2, 3, 4, 5, 6, and they travel a certain amount of distance. So during the first hour of their bike ride, they were riding at a constant rate of change, and that's different than this type of constant. Okay? So in this first hour, they rode about 10 miles. In the second hour, you'll see it's not as perfectly straight. Maybe there were some hills, and they were going a little bit slower, then they sped up, then they were going a little bit slower, then they sped up. So you can kind of see what's going on in this next interval here, from 1 hour to 3 hours. They are riding their bikes, and they are traveling a certain amount of miles, but you'll notice there's little bumps in this road here. In a graph, that means that your speed is changing, your distance is changing. In this one, what do you think happened here? So from 3, let's say it's 3 o'clock, to 4 o'clock, let's pretend those are our time of the day for the sake of making sense. Between 3 and 4, did they travel any distance at all? So it looks like when you move from left to right, there's a distance. But when they stopped riding at 3 o'clock, let's call it, maybe they were at 32 miles. Well, how far had they ridden their bike at 4 hours? I'm just estimating a number here, 32 miles. So, did anything happen between 3 and 4 o'clock? Did their distance change at all? No. So it appears as though in a graph, a constant horizontal line means that you didn't make any progress at all. So I might say they took a break. Maybe they went and ate some lunch, right? But for 1 whole hour, their distance did not change. So their bikes were parked. All right, one more graph. Describe the graph from the interval of x equals 0 to x equals 2. Pause the video and actually write a sentence. All right, do you know where x is 0 and x is 2 is located? Here's x is 0, here's x is 2. So you should be only looking in this area. And if you're looking in that area, what is the graph doing? Remember, you read from left to right. So if I'm reading from left to right, what do my eyes do? Do they go up or down? Increasing or decreasing? Do they move perfectly straight or nonlinear? So hopefully you said that the graph is increasing because it's moving uphill from left to right, and it's nonlinear. It's not perfectly straight. There's a bit of a curve here. All right, it's time to check to see what you know. We're going to move over to Desmos and answer a few questions.